Hello everyone and nice to meet you. My name is ATM Math and today we're going to learn about differentiation. Today we mainly learn about three key concepts. Firstly, we're going to learn how to differentiate things. Secondly, we're going to learn real-life examples of differentiation. Thirdly, we're going to learn about differential coefficients. Okay, now let's start with new concepts before we begin our main lesson. Firstly, we need to see what is average rate of change and instantaneous rate of change. In the average rate of change, we just need to know when there's 2 points and there must be one line connecting these 2 points, then the inclination of this line is called the average rate of change. And in the instantaneous rate of change, when we have a point and we draw a line that only has 1 point matching in that point with the function, then this function's inclination is called the instantaneous rate of change. Now, nextly, we're going to learn how to differentiate. Now, how are we going to differentiate? Let's say we've got a function fx, which is like 6x squared. Then, if we differentiate it, differentiation, we should know how to write the symbol of fx differentiated. We write it as f prime x. And how we do it is very simple. Even though this is very, very, very hard in the high school mathematics calculus, it is pretty easy. So we have a 2 in the back, right? And if we subtract 1 from 2 and multiply 2 in front, then this becomes 12x, 2 minus 1, which is 12x. So f prime x is 12x if fx is 6x squared. So what we're going to show is that if axb plus cxd, something like this, and on maybe, we just need to know that these are going to get differentiated, like fx equals this, and we're going to differentiate fx to f prime x. But if you differentiate it, then it just becomes b times ax b minus 1 squared plus c dcx plus d minus 1 squared and on. So you should just remember, if you differentiate a function with a lot of equations and pluses and minuses, just break them into parts and do it separately and then plus it or minus it as they want, okay? So we learned about how to differentiate it, and nextly we're going to learn about differential coefficients. Now, differential coefficient is just a hard word for instantaneous rate of change, so it's just the same. So just remember that if you've got a function like this and we have a point like this, if you draw a function that only meets this one point at this function, and this inclination is what we call differential coefficient. And now we're going to learn about how to calculate it as in a calculus way. So let's limit x to a set point called a, and the a is right on here. This is a. So if x goes to a, it might be this way or this way. Let's say this way. Without loss of generality, we're going to just say it's this way. Now, if x goes to a, it goes like this. Then what I've got to tell you is that if we need to calculate the differential coefficient, we have 1 point, right? We have 1 point, and we need to calculate the instantaneous rate of change. Okay, now we just need to know, how are we going to calculate? This is very simple. If you take this to the next level and see it with a magnifying glass, then it's going to be some kind of this line. Then we just need to calculate this much line's inclination. But this is x and this is a, right? So this much is x minus a, and this much becomes fx minus fa. So how do you calculate it? As we learned it, how do we calculate the inclination? We know that the changed amount, delta x, and changed amount, delta y. Then we should calculate the inclination as delta x under delta y, right? So how do we do the instantaneous rate of change, aka differential coefficient? As I told you, delta x under delta y is same as fx minus fa over x minus a. So x minus a under fx minus fa is the differential coefficient. And how we calculate it is this way. But what you're gonna get surprised is that we also have one more way, but it's almost the same. Let's limit delta x as 0. So delta x is, maybe we have a, and we're gonna have a plus delta x. But we know that a plus delta x is almost same as a. So we're gonna use the same method. We use a very cool magnifying glass, and we have a and a plus delta x. And we have this much of a triangle. And we need to know the inclination of this much. This much is delta x, since a plus delta x minus a is delta x. This much is fa plus delta x minus fa. This is because this is fa plus delta x, and this is fa. So we just minus it, okay? But we also know that if you have the change amount, delta x, and change amount, delta y, we know delta x under delta y is how we calculate the inclination. So the differential coefficient in the second way is limit delta x to 0, and delta x, since this is a plus delta x minus a, it becomes a minus a, so this becomes 0, and this is only delta x, okay? So this is delta x under f delta x plus a minus fa. Okay, so these are the two ways to calculate the differential coefficient. So x goes to a, x minus a under fx minus fa. And if limit delta x goes to 0, delta x under f delta x plus a minus fa. These are the two methods to calculate differential coefficient. And most students will be wondering and having a problem. Just why do we learn this? Just why do we learn calculus? Where do we even use it? We have nowhere to use. Where do we use calculus in real life? Now, nextly, I'm going to show you how differentiatives are used in real life. So, in a car, we have a gauge behind the handle showing the speed, right? Yeah, in real life examples, the gauge, the dashboard at a car uses differentiation. This is surprising and absurd, right? Like, you're becoming like Nick Young and be like, what? And I'm just going to tell you that this gauge has a secret calculation. So let's just think of me taking a photo of a car speeding at a highway. And your car must be speeding, but it looked like you're stopped at my photo. But you're going 80 kilometers per hour. Or let's just say 60 miles an hour. So if you're going 60 mph, you just need to know, well, you're stopped at the photo and how you become 60 mph. How does the car calculate this? This is very easy. This car is manufactured to know differentiation. So we have a graph like this. This is time, and this is how much you moved. So how much you move is this way, and time is this way. Now, let's think of this. You start from a little bit over, and since you went down, you went here, and a little back, and just over again, and back, and you just suddenly speed it, and go like this. So, if you decrease by how much you move, then that means you went backwards. You reverse your car. But if you go forwards, you just speed your car. Okay? So, how does a car know if your car is 160 mph or just minus 14 mph? This is just 14 mph reverse, you know? How does the car know it? Since we talked about differentiation, you must know that it is related to differentiation, but just how? We can think of one point at a time. Let's just draw one point, a lot of points, and we can think what the differential coefficient is. At here, 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 at here. Then the inclination of this is the differential coefficient, right? You know? This inclination is just the differential coefficient. And this is instantaneous change. Instantaneous change. What does instantaneous meaning? This means instantly, just a moment. So instantaneous change is differential coefficient, but that only happens in just a moment. So how we calculate this is just a moment. In just a moment, we can calculate the differential coefficient, which is the inclination of this function, meeting at only one point with this function. So in real-life examples, we can think of gauge or dashboards at a car. And if your car has a gauge, that means that your car is manufactured to use differentiation and learned it. Yeah. Today we learned about three main concepts: differential coefficient, what is differentiative, and real-life examples of gauge dashboard at a car uses differentiation. If you need help, watch again till you understand. But if you really need help on differentiation, please contact Aiden Teaches Math at gmail.com or Aiden Teaches Math at naver.com. This was Aiden Teaches Math, and see you next time with another episode of Math. Thank you for listening.